Okay, so just as a side note, the power went out, but we're still going to be able to do class. I will not be making quiz 3 though. So we have quiz number 1, quiz number 2, each at 2%, and that's it for quizzes. Okay, let's do notes. So I would like to finish 5.1, and that's the goal. We can continue chapter 5 next week. Just going back to the last thing we did, which was the area under a curve. So the area, I'm going to call A. Under the graph of a function f, actually we want to make sure that it's a continuous function. Okay, so A for area. And we got to the part where it's equal to the limit as n goes to infinity. Of a bunch of rectangles where you have a width delta x multiplied by your height f of x sub I star. So this first one would be f of x sub 1 star add delta x f of x sub 2 star. And then you continue to add till you get to the last rectangle, which is width delta x and height f of x sub n star. So for this piece, we can use summation notation, and then we're going to talk about these x of 1 star, x of 2 star, the x sub I stars, what those are and where they come from. Oh, the limit as n goes to infinity. We're going to sum from I equals 1 up to n. Summing up all of those rectangles, f of x sub I star multiplied with the delta x. Ooh. Okay, so let's draw a picture. X-axis and y-axis. We'll talk about an interval AB. Go over from A until you reach B. And then for your function, we'll just swoop. Called F. Okay, looks okay. And then A is called x naught. B is called x sub n. So your first part of your partition. X naught followed by x1, and x2, and then dot, 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 to however many until you reach b, which is x sub n. And then the idea, and of course we're going to do examples, but the idea is on the first interval, we draw a rectangle and get that area. And then another rectangle, here, here, however many you need to get to B. Okay. X sub I stars. These are from the subintervals. So x of 1 star is some value between x0 and x1. x2 star is somewhere here between x1 and x2. So here, x of 3 star is a sample point between x of 2 and x of 3. Or in the third interval, pick a sample point x of 3 star. Okay, so the ith interval that goes from x of I minus 1 to x of I and includes both of the endpoints. Usually we'll either go and get a left-hand endpoint or a right-hand endpoint. Let's see. Oh, whatever, we'll practice. Or a midpoint. But really you can pick any x of I that you want to. It doesn't have to be right in the middle. It could be somewhere like towards the middle as your sample point for the height of your rectangle. And remember, all rectangles have width delta x. Okay, so in your interval, you pick an x of I star, and then use that x value to get the f of x of I star, the height of your rectangle. And after that, you'll take your height times your width and find the area of each of the rectangles. X of I star is your height. So I've got two examples, or I have an example broken into two types. Two parts. The function is f function of x equal to 25 minus x squared. Okay. So we're going to use the interval from 0 to 3 on part A, and then we're going to go from 2 to 4 for part B. Use right-hand endpoints to find the area on 0 to 3. Actually, we're just going to set up the equation for, yeah, it's an equation, a formula for the area. For the area. This interval. Cool. Let's draw a picture first. So this would be an upside down parabola, and the vertex is shifted up to 0, 25. Over here. Sketch. So we'll come over here, but actually we just want this side from 0 over to 3. There's an intercept at +5 and -5, so we'll go over to +5. Curve. Okay, we just need from 0 to 3, so go over 1, 2, 3, straight up to your function and shape. We want that area. Let's find delta x. Delta x. B subtract a divided by n. This is my a. Okay, 3 minus 0 over n. And just leave it as 3 over n. Next, we're going to talk about the right-hand endpoints. So let's get a bigger picture from 0 to 3 and just draw the x-axis. I don't need to label that part. Let's just put 3. That can go. 0 would be x1, the first x value. 3 we call x sub n. Okay, after x sub 0, there's x sub 1, x sub 2, x sub 3, keep on going. Depending on n, you'll have like different amounts of rectangles or a different number of subintervals. So let's say you keep going some amount, get here to x sub I. Until you reach x sub n. Each interval has a width of delta x, so a width of 3 over n. This time, since you're starting at 0, we'll go from 0, add 3 over n, which means x sub 1 is equal to 3 over n. Okay, so this would be 3 over n and another 3 over n, which makes x sub 2 6 over n. Okay, 3 over n plus 3 over n plus 3 over n, we're at 9 over n. And then you keep going some number until you reach x sub I, and the formula would be, let's see, 3, what did I do? Put 3 times I over n. So just check that out, where here I equals 0. So let's go think. 3 times 0 over whatever number n is 0. So that works out. Okay. And then 3 for x sub 1, we have 3 times 1 over n, 3 over n. X sub 2 would be 3 times 2 over n. Getting there. X sub 3, just checking. Do I have 3 times 3 over n? Yes. Since we were choosing these right-hand endpoints, those are the sample points. Your x sub I stars will be 3 sub I over n. All right, so putting this into that formula for the area, we have also found delta x, so we'll replace that piece, and then we'll just kind of simplify the limit. There's a limit. As n goes to infinity. I'm just going to write it out in general. Your sum from I equals 1 to n of x sub I star. Delta x. Okay. The limit as n goes to infinity. Your sum from I equals 1 to n. Let's actually put 3i over n into the function. So your function was 25. Subtract, plugging this number in, and then square it. And then also we found delta x. It was 3 over n. And now it's just a matter of working through this kind of algebra here in the summation. So what we'll do is square that part. I got a 9i squared divided by n squared and multiply by 3 over n. Okay, distribute this piece here and over there. So, 75 over n, subtract 27i squared over n cubed. So, next step. Limit as n goes to infinity. Sum from I equal to 1 up to. So 75 over n minus 27i squared divided by n cubed. And I think we're done. Yeah. That's as far as I want to go with this. part B, we have the same function, same idea, but we're going from, let's see, we want to do 2 to 4. I'm not going to rewrite the function. We already have that part. We're going to say use right-hand endpoints like last time. To find a formula for the area on to the interval that goes from 2 to 4. Okay, so again, I think we should draw a big picture, and we'll enhance the interval that we're on, this one. And then we'll break it into subintervals, piece everything together. It's f of x equal to 25 subtract x. Same upside down parabola. But we want 2 to 4. So at 2, find f of 2. And from 4, go up to f of 4. And we're going to find all of the area under there by filling it full of rectangles. Let's get delta x. This time, take 4, subtract 2, divide by 10. 2 over n. And we want to talk about the x of I stars, and you're using them as right-hand endpoints. So I'm just trying to draw an x-axis. And I want x to 2, 2. So you start at 2 and add delta x, and another delta x, and another delta x. So add 2 over n. So this x one. Let's get you to x. And then another delta x, x of 2. X of 3. Let's put x, squeeze in an x of I minus 1 and up to x of I. So the previous value, x of I minus 1. Then after that is x of I. Until you reach the last value, x of n. So x naught equals 2. next one is 2 plus 2 over n. X sub 3, oh no, x1, x2 is 2 plus 2 over n and another 2 over n. So 4 over n. Okay, you get to x sub 3 by starting at 2 and then add 2 over n, 2 over n, 2 over n. So you're going to add 6 over n. Let's go on and try to figure out x sub I. A right-hand endpoint would look like 2 plus some number we'll piece together. Yay! Okay, happy. So 2 plus 2i over n. Double check it in a sec. I think I'll check. Okay, so the first I is a 0. I had 2 plus 0. Cool. Second I equals 1. 2 plus 2 over n. Checks out. I put in a 2 right here. We have 2 plus 4 over n. Nice. I think this is good. Let's see if we have I equal to 3. 2 plus 2 times 3 is 6 over n. Okay, and these are my x, y stars. Because we're doing right hand. Cool. So we're going to put in our delta x. We're going to plug in x sub I star to the function f and get all of that together in the limit. Limit as n goes to infinity of the sum from I equals 1 up to n of, I think we should just go ahead and put out what it is in general. X sub I stars with your delta x. Okay, and we'll put in what that actually is. Sum. This goes into the function. So it's going to be 25 and then subtract this piece squared. Okay, let's see. Okay, that's that. Multiply with delta x. So you multiply with 2 over n on the side. So we've got everything where it needs to be. We just want to simplify this limit. Let's take care of this piece first. And yeah, we've got time. Yes, we're going to finish this section. Okay, n goes to infinity, and then your sum goes from I to n. I equals 1 up to n of 25 minus 4 plus 2, 3, 4, 5, 6, 7, 8. 8 I over n. Plus or I squared over n squared. So that's just being subtracted. Actually, let's use this would be parentheses. Okay, and then times 2 over n. We're just going to distribute the negative sign, put those values together, and see what happens. All right, the limit as n goes to infinity. Of the sum from I equals 1 up to n. And it's going to be 21 minus 8i over n. Subtract 4i squared divided by n squared times 2 over n. Let's distribute 2 over n. Okay, we have 42 over n minus 16i over n squared minus 8i squared over n cubed. And we're good. That should be that. All right, it's the end of 5.1. And I feel like that's a good place to end class. So I'm going to try to make some homework, but we will not do a quiz 3. That's it. Have a good weekend.